Hi, this is Mr. Erlin. Welcome again to another lesson in geometry. Today we're working with algebraic proofs. The environment's called a two-column proof. And in geometry, we can find two-column proofs as a cornerstone of a lot of what we're doing to demonstrate that something is true. The hallmarks of a two-column proof include a table structure like this, also sometimes called a T-table. We expect the column on the left to be headed with the name statements, column on the right to be headed with the name reasons. We also should be given some information and asked to prove some information. This is the structure of a two-column proof in any environment. Once we get this information, we should be able to take what's given to us. In this case, this algebraic expression, it will always go in the first statement. Our first reason is always going to be given. Now, this is one step easier than traditional algebra because in addition to giving you the problem, we're also giving you the solution. The solution is what you're trying to arrive at. This is what your answer should be. We're saying that at the end, our final step will say x equals 5. What I've set up here for you is what we can expect from every single proof. Now let's go through the process of this particular proof. In this case, we've got an algebraic expression we're trying to solve. We know that the first step in an algebraic, that should be a 1 because it matches. It's the reason for this. The first step in an algebraic solution is to isolate the x's, move all the x's to one particular side. I'm going to choose to move this 2x over to the right-hand side. Now normally in algebra I'd write minus 2x and minus 2x, and that would be the way I'd show my work. However, in geometry we'll show our work a little differently. What we'll do is demonstrate what exactly in geometry, what we'll do is we'll demonstrate what we're doing and then we'll give an explicit reason or a justification for why we're doing it. So if I'm going to subtract 2x from both sides, my result would be 3 is equal to 3x minus 12. Why was I allowed to do that? I was allowed to do that because of the subtraction property of equality. Note, that's different than the subtraction process itself. The reason we call it a property of equality is because we're doing it to both sides of the equation and thus retaining our equality. The third step then is to get my numbers all isolated to one side. So I'd want to say plus 12 and plus 12. But instead of writing that, I'm going to simply show what the solution is or what the result is and then justify it by saying that I added the same thing to both sides. Addition, property of equality. And I'm okay with you having shorthand notation here as long as you're clear and explicit about what you're saying. Step 4 is I want to isolate just one x, so I'm going to divide both sides by 3. In doing that, I get 5 is equal to x. Not surprisingly, that's the division property of equality. Now, am I done? Is this exactly what I wanted? Well, it means the same, but it's not quite finished. My last step would be to specify that x is equal to 5, which exactly matches my proof. And this is a step that you might not know. It's called the symmetric property of equality. And this is one of the several properties of algebra, properties of equality and properties of congruence, that you'll need to memorize in this unit in order to be able to successfully write what you're doing. And in the end, when we've completed the proof, when we've accomplished our mission, we like to sign off by writing QED. It's kind of like dropping the mic. Yeah.